Picking up at question 9 for the homework paper, 2017, Unit 2, going through the questions from here to the end. Starting with question 9, we're told we're dealing with an isosceles triangle. Isosceles triangles have two sides that are the same length, but more importantly for us, they have two angles that are the same size. Knowing that these two angles are the same size, I can make a little algebra equation that will let me find the value of x. And then when I have the value of x, I can use that to find the value of y. So here my equation has x's on both sides. I start by taking away the smallest number of x's. Because of the take away 3 in the equation, I'm going to add 3 because we always use the opposite. And as 3x equals 51, I'm going to divide by 3 to find one value of x. 51 shared 3 ways is with 17. This isn't the end of the question, that is just the x value. And if I go back to the original diagram, I can see that this angle here was that x value plus 48. Because they're isosceles, I know that this one is also 65. So for angle y, it's the 180 total for the triangle. Take away those two 65s. That would be 180, take away 130, and the y angle is actually 50 degrees. Question 10. Powers and indices, and when you have powers being multiplied together, to find the new power you add. So p to the 6 times p to the 3 will become p to the 9. Dealing with the actual numbers, where we have that 6 there, multiplying that's 3, 6 times 3 is simply 18. So I'm looking for 18 p to the 9. Division means that to find the new power you subtract g to the 8 divided by g to the 2 gives me g to the 6. And this is with a calculator because we're on the calculator paper. So 3.4 divided by 13.6 gives me a quarter. So I'm looking for a quarter of g to the 6. The last part, we've got multiplication and division. So to find the new power on the top, I'll focus on the m3 times the m6, which gives me m to the 9. So this bit is with m to the 9. And then to find the value of the overall answer, I got m to the 9 divided by m to the 9. That take away the power, you'll end up m to the 0. And anything to the power of 0 is with 1. Question 10 is a trial and improvement question. This is a very specific method, and this 4 marks is very straightforward. So this is a topic you should know, and it's not the strongest at the moment, so you should practice this. First of all, knowing that my answer's got to come between 4 and 5, my first value to try will be 4.5. On the calculator, I will type in 4.5 x cubed key plus 2 times 4.5 and press equals. Typing this in on the calculator is going to give me my first value. It comes out as 100.125, which is too big. So because this is too big, the next x value that I try will need to be smaller than 4.5. So this time I'm going to try 4.4. A common mistake is to change the 4.4 where it goes in as the x cubed value, but to leave 4.5 in the second part of the sum. But if x is 4.4 there, x is also 4.4 there, so make sure you replace both. 4.4 cubed plus 2 times 4.4, my calculator, gives me 93.984. Still too big. 4.3 is my next go. 4.3 x cubed plus 2 times 4.3. You can just scroll back on the calculator display and change the 4.4s to 4.3s using the delete key. Saves a bit of time, but you've just got to be careful you don't delete the wrong part. That gives me 88. I'm trying to get to 91, so that one's too small. So at the moment I've got 2 marks because I've found a value that was too big and a value that was too small. I have to do the check or I can't get the 3rd mark, and the check has to be halfway between the 4.3 and the 4.4. I'll do the same calculation again now, but with 4.35. Type it into my calculator, 4.35 cubed plus 2 lots of 4.35, and I'll get 91.01285. It's pretty close. It's just a tiny little bit too big. Doesn't matter if it's close or not, because it's too big, I have to pick the best possible answer. 4.4 was too big, 4.3 was too small. One of these is going to be my chosen answer. 4.35 was my check value, which was also too big. So this tells me that 4.4 would be absolutely too big, and my final choice will be 4.3. That's your 4th mark. That final choice and picking your final answer is the 4th available mark. So you get a mark where the stars are, a mark here for doing 4.35, and then the final mark there for picking the right answer of 4.3. Question 12, we've got a triangular prism. The triangular prism here, we're told it is 2 meters long, but the rest of the measurements are given in centimeters. So I'm going to go and change that to 200 centimeters before I do anything else. You can't mix units. If it's centimeters in one place, it's got to be centimeters everywhere, or meters everywhere, but centimeters are easier to deal with. Question says find the area of the triangle. To find the area of the triangle, I need to do base times height divided by 2. Unfortunately, I need the base and the height to divide by 2, and at the moment I don't have the base. That's the AB side, and I don't have the base of the triangle. So I'm going to have to find that before I can find the area, and that's why this is a 5-mark question. It wouldn't be a 5-mark question just to do with area. Now, the topic that you need to be able to find the side of a right-angled triangle, given the other 2 sides, is going to be Pythagoras. Pythagoras is a 3-step question, and to find AB, the side here that's missing, I'm finding a short side. You have the choice of short or long sides on your right angle triangle, and I'm finding the short side. Pythagoras finding the short side is subtract. So you've got square, subtract, square root. That's how I remember my 3 steps. So the first thing I need to do to find AB is remember that I'm finding AB squared. So I square both of the numbers, then I subtract, and then I square root. So I square both of the numbers, then I subtract, and then when I square root this now, I actually get the length of AB. AB is not 784. AB is the square root of that, which is 28. So AB is actually 28 centimetres long. And now I've got all my information, so I can find the area. Area equals half times the base times the height. 294 centimetres squared. Okay. In part B, it wants the volume of the prism. So to find the volume, I'm going to have to turn back a second because I'm going to need the area of the triangle. Because to find the volume, I do the area of the front of the shape, which we call the cross section. And we multiply that by the length of the shape. So if I turn back a second, the length of the shape is this 200. The area of the front is this 294. 294 is the area of this cross section. So to find the volume, I simply have 294 multiplied by the 200. You've got to give the units of your answer. So if I simply do 294 multiplied by 200 and I write down 58800, 58,800, I've only got 2 marks. I have to put centimetres cubed on the end for that third mark. LCM and HCF. Find the answer to the following number problem. The LCM of 12, 18 and 24 divided by the HCF of 36 and 54. So this is a 3-part question. Part 1, find the LCM. Part 2, find the HCF. And then part 3, do that division. So part 1, for the LCM, the lowest common multiple of 12, 18 and 24. If I do the 12 times table, and then I do my 18 times table, and then I also need to do my 24 times table. So I'm just going through these on the calculator because it's a calculator question. And I'm not going to do many more because I think I've spotted a common multiple. The lowest common multiple of 12, 18 and 24 is the first time in this table now that they match. And I can see that they both have 72. So this first part, the LCM of 12, 18 and 24 is actually 72. It's the first time they match. And then I need the highest common factor of 36 and 54. So for the highest common factor, 36 and 54. So if I list the factors as pairs, 1 and 36 because they multiply to give me 36, 2 and 18 because they multiply to give me 36, 3 and 12, 4 and 9. 5 doesn't work. 6 works as a repeated factor of 6 sixes. And as soon as I've got to that middle ground and I start working back up that right hand side, I know there's no factors left. So for 54, 1 and 54. For 54, 2 and 27. For 54, 3 and 18. 4 doesn't go into 54, so that's not a factor. 5 doesn't go into 54, so that's not a factor. 6 goes into 54. So 6 and 9, 6 9 is 54. 7 doesn't, 8 doesn't, and as soon as I'm back to 9, I know that I can stop. So I'm looking for a common factor. For 36 and 54, I'm looking for the biggest number that's in both. They've both got 1, they've both got 2, they've both got 3, they've both got 6, they've both got 18, they've both got 9. But if I'm looking for the highest common factor out of those that I've highlighted in yellow now, the highest number is actually 18. So the highest common factor is 18. So the answer to my question, 72 divided by 18 equals 4. Question 14. Rearrange the following to make x the subject. This means we've got to rearrange it till x is on its own. At the moment x is here, smack bang inside a bracket, surrounded by y's and 2's. So step 1 will be to multiply out the bracket. Everything inside the bracket has to be made twice the size, or multiplied by 2. Step 2 will be to move that 2y to the other side, so that it's with the 7y, leaving the 2x on its own. So now I have 2x equals 5y minus 3. And the final step will be to divide by 2. So 5y minus 3, all divided by 2. X is now the subject of the equation. Question B wants the nth term. To find the nth term, I need to look to see what times table this is based on. So the first thing that I do is I see what's being added each time. For this first step, it's add on 3. For the second step, it's add on 5. Then it's add on 7. And then it's add on 9. Because this isn't one number being added repeatedly over and over again, this is not linear, and this is going to be based on my squared numbers. So because I can see the 3, 5, 7, 9, my actual work has to be dependent on the n squared numbers. So 1 squared is 1 times 1, 2 squared is 2 times 2, 3 squared is 3 times 3, 4 squared is 4 times 4. And I've got to try and find the link between this square number and the number in the pattern, this square number and this number in the pattern, and so on. I know it's squared numbers because I didn't have one constant for this line of adding. Because it's changing every time, I know that's my clue that I'm dealing with squares. So if I looked from 1 to 3, got to add on 2, 4 to 6, add on 2, 9 to 11, add on 2. So this is my squared numbers plus an extra 2. Question 15. As soon as I see that I'm dealing with angles and sides, I know that this is a trigonometry question. So the very first thing I'm going to write down to help me throughout will be SOHCAHTOA. This groups my sine, cos and tan with the two sides that are important, opposite, hypotenuse or adjacent. This is going to be for a 6-mark question, a 2-step question. So I can see angle X here is in this yellow triangle. But I can also see that if I want angle X, I know the opposite is 15, but I don't know anything about the hypotenuse or the adjacent. So I have to find that first. But the adjacent is also part of this triangle. So if I've got any chance of finding something helpful, it will be this number here. So let's go back, get rid of all that. So the first thing that I'm going to do is look for this side here, and I'm going to call it SQ. Drawing myself a little triangle to focus on just the one for SQ. If I'm trying to find SQ this side here, I'm going to call it Y actually. Then I need to label my triangle with opposite, adjacent and hypotenuse. So this would be the opposite, this would be the adjacent, and this one would be the hypotenuse. As I'm dealing with O and H, I'm dealing with sine. So trigonometry tells me sine of 38 is equal to the opposite divided by the hypotenuse, and it's the opposite there, the y side that I'm trying to find. To find the y side that's on a division, I'm going to need to swap them and divide the 8 by sine 38. That is it. That's going to tell me y in centimetres. So on my calculator, 8 divided by sine 38, 12.99. So SQ here in the picture is 12.99 centimetres. So back to the second triangle, because now I can focus on the x angle, which is my actual question. So back to the second triangle where we had x here in the bottom corner, 15 there for RQ, and until now I didn't know anything about SQ, but I now know it's 12.99. Drawing the little triangles helps you focus on what information you're given that's useful, instead of looking at the whole picture in one go. Now if I want to find the angle, I need to label it. So this will be the opposite, hypotenuse and adjacent. And this time when I think about SOHCAHTOA, I have the adjacent and the opposite, which is tan. So trigonometry tells me tan of angle x is equal to the opposite divided by the adjacent. Angle x is tan to the minus 1, inverse tan's moved over to the right hand side of that 15 over 299, 12.99. So shift tan on my calculator, 15 divided by 12.99. The x angle comes out as being 49.107. Two-step equation. So in my first step of the equation, I had to find the length of SQ, and in the second step of my equation, then I was ready to go and find angle x. Question 16, tree diagram. Reading the information here at the top, all of the members of a farming club visited the Royal Welsh. They all travelled to the show either by bus or by car. None of them visited the show on more than one day. The decision to travel by car or by bus was independent of the day. And now we're talking about a member of the club that was selected at random, and the probability that the member travelled by bus was 0.87. There it is. The probability that this member visited the show on the first day, 2/3. There it is. So to complete the tree diagram, the probability of bus or car must come to a total of 1. So 1